YouTuber. In this video, I'm going to show you how you work through this problem on circle geometry. We adopted this question from 2021 November ZIMSEC paper 2. Okay, so this was the first question that was there. So the problem statement, it reads, in the diagram above, this diagram originally it was above, okay, so in the paper. So you're told that the points on the circumference, the points are A, B, C, D, and E. So all these points here, they're actually points on the circumference. Okay. So you're told that the circle has center O, so this is O here. So this should be fine, this should be fun. And you're told that RCT, so which is this line right here. So this line right here, you're told that it's a tangent. If it's a tangent, it simply means that it touches the circumference of a circle only at one point. Okay, so in this point, in this case, the point is C, so which is good enough. And then we are told that BCE simply means the angle is formed at C coming from B going to E. So you can just go to C right here. Okay, so this is your C, and then coming from B, so it'd be this angle here. Okay, so coming from B, so it'd be B to C, then to E. So it's this angle right here. So given that it's 50, it's 53, and then EAD also, you can also figure out which one is EAD. Just go from E, and then the angle is formed at A, and then you have D here. Okay, so you're given that it's 48. So this is fun, this is good. And you're asked to name the angle which is equal to ADE. So you have to ascertain which part is ADE. So DE would be this angle right here, but then we don't have the other leg for DE. So what I'm going to do is to actually put that other angle for that other side for DE. Okay, so it's right here. Okay, so this one would be for DE. So we'd have ADE as this particular angle here. Okay, so we can actually call it theta like this. We're supposed to name the angle which is equal to ADE here. This angle here. Okay, so what you can see here is that you have this particular, if you can see, there is this particular section here. I want you to concentrate on this. Okay, so you can see it's this particular section right here, and then in this particular section here, these two angles, they actually share a chord. So this angle and this angle, they actually share a chord. Their chord would be DC. Okay, so in the same sense, these two angles, which is the angle that we're looking for, and this particular angle here, they share a chord. The chord is AE. Okay, so the chord is AE. So if they're sharing a chord, it means that the angle subtended at the circumference, they must be the same. Okay, so the other angle would be this particular angle right here. Okay, so let me actually just try to shade it. To shade it. Okay, so right here. Okay, so it's this angle right here. So the angle would be, the way that you'd name the angle would be ACE. So the angle that you're looking for is ACE. So let me write here. Okay, so the angle is ACE. The angle is formed as C coming from A and going to E. Okay, so it's this particular one right here. So that's it for this part, and what I will do is to wipe off probably everything. We didn't put any details there, so it's fine. So now we're going to calculate BEC. So BEC, we should make sure that we know the angle that they are talking about. So from B to E then to C, it should be this particular angle right here. Okay, so they want us to calculate this angle. So if you can see triangle CBE or EBC, it's actually formed from the diameter. So EC is the diameter. So if it's the diameter, it means the angle subtended at the circumference by the diameter. It must be right angle. So this one you're dealing with the case of 90 degrees. Okay, so since you know that this is 90 degrees, you can calculate this by saying 90 degrees minus 53 like this. Okay, you can use a calculator if you want. This is paper 2, but then we are not going to do that. We're just going to simplify. Okay, so you actually get 7 here, and then here you get 3. Okay, so you get 37 at the end of the day. So I'm going to write this is 37 like this. I'm going to wipe off everything again, and then we'll input 37 on BEC. Okay, so BEC will put 37 here. Okay, so this one, it's equal to 37, just so we don't forget. Okay, so afterwards we calculate BAE. So BAE. So it's B, then A, then E. So we are supposed to have this side as well, which we don't actually have. So we're going to put it and then up to E. So they're looking for this angle right here. Okay, so this is the angle that you're looking for. So this angle here, you use this theorem. If you observe A, B, C, E, this is a cyclic quadrilateral. Okay, so let me actually try to share the shape that I'm talking about here. So it's this whole shape here. It's a cyclic quadrilateral in the sense that you have 4 corners here, and the 4 corners, they're actually touching the circumference. Okay, so this is a cyclic quadrilateral. In a cyclic quadrilateral, the opposite angles, they add up to 180. Okay, so they complement each other. They add up to 180. So in that sense, we can actually calculate BAE by saying, so BAE would be equal to, would say 180 subtract 53. Okay, so 180 degrees subtract 53 here. So you'd end up getting, this one would be 7 obviously from here, and then this one would be 6. So here you get 2, then here you get 1. Okay, so at the end of the day you get 127 here. So this is what you'd get. Okay, so we just used the theorem for a cyclic quadrilateral, that the opposite angles, they must help each other to get to 180. Okay, and then on the next part, we are supposed to we calculate DOC. Okay, so DO then C, so it's this angle here. Okay, so you want to find this angle here. One way to figure it out is to intuitively, I think if you think this is an angle subtended at the center, so it must be twice the angle subtended at the circumference. Okay, so you'd have to look for the angle subtended at the circumference. It's this particular angle right here. Okay, but then there's a problem. We don't actually have the value for this. We have the value for this other one. Okay, so if you want, you can actually say, since you have 48 here, you can say 90 minus 48, then you get 42. So this one would be 42 here. If it's 42, then this one would be 84 degrees like this. Okay, so this is one way you'd go about it. If you don't want this, what you can do is to find this angle right here. Okay, because this angle right here, it's twice the angle. It's twice this angle here subtended at the circumference. Okay, so this one would be 48. So 48 multiplied by 2, then you get 96. So you can write 96 here. So this one would be 96. To get this axis angle, what you can do is you can say 180 minus 96. Okay, so you end up getting 84 degrees anyway. Okay, so this is just how you go about it. It's not very tough. Okay, so I hope you really learned a lot from this one. Okay, so this was really fun for me. I hope it was fun for you as well. I loved answering this question. Okay, so make sure you like, share, and subscribe, and also just put in the comment section if you need any assistance with anything. So this was fun. Thanks so much for watching. Make sure you like, share, and subscribe. Yuba out.